At this point, we start doing something a little bit more properly. We define the shape of the data and we start shaping our domain using a little bit of clean architecture. So what's a domain? You guys know the guy, the Uncle Bob. He's a guy advocating the clean architecture. He wrote a lot of books and I gave him a lot of money, but they are good. They are meant to be used more for backend, probably backend, Java, Word, sort of things, but you can take inspiration from his approaches of trying to having a little bit of separating of concern. And one thing that you want to think about when you're building your applications, and which I think is making you a senior developer, is trying to build the internal components of the application, the internal modules, not real components, the internal bits and pieces in a way that there's a little bit of abstraction, and also we are using contracts of and interfaces to describe the types that we're using. Yeah, let's do it. So let's explain the clean architecture concept with the help of this graph. You can see that there are multiple layers from the core to the external part of the circle. We have entities in the center, use cases, and then another layer, controllers, and then something external like web devices, UI. This is usually being used mostly in the backend to organize and to have a solid structure of an application, but it can be used in the front end as well with good result. Entities, they are like the mutable part of the application, something like related to the entities of the business logic. Could be client, order, cart, things like that. Like the description are usually the entity description of these business objects, entities. Use cases, here comes more interesting. We would find something like add to cart is a use case, or authenticate, login is another use case. It's more like the algorithm part where you would find the logic of how things happen using the entities. So there's some sort of dependencies which goes from the outer part of the circles to the inner part. The dependencies always happens, remember this, from outer to inner. So use cases are using the entities inside. And this is kind of sort of, if you want to think about an example, the old model view control, where the model was using, the controller was using the model parts, which are then implemented in another way, but the core algorithm, the core business use case stays in the use cases, and then it uses the entities. So how about we go one level up? We have a controller's gateways presented, but it's not important at the moment, these terms. Let's just focus on this method going from inside to outside and how they are related. Let's say you have a use case like, for example, add to cart, and you write the code in TypeScript for adding to cart. Then you use the cart itself. We have all the algorithm, and probably we add a little piece of code to add the items into the array. But how are we going to use this thing? All this code written for the add to cart would be completely independent from any framework. It would be agnostic to each framework. And when we can use it, for example, in a framework like React, we will need to instantiate this use case and then use it elsewhere. So in theory, the fact that we wrote the add to cart independently allows us to use the same use case in different frameworks. So it doesn't have to be React. It could be Vue, it could be Angular, and so on. See another representation of the clean architecture. This one, ironically, is about cart and product. So we have the domain where we have product, order, cart, user, which could be interfaces in TypeScript, for example. And then we have the application, which are the actions that we perform on this domain. So we have the payment, validation, and here we can see the little circle are sort of gateway, how to they open a door to the external world. What they say, people who are following clean architecture approaches, the more you are in the core of this graph, the less you want to touch it. It's like the pure definition. And when you go on the outer part, you are trying to move into the sort of real world usage of this domain and application use cases. It's a sort of philosophical approach where the domain is like the idea itself, and then you move to the real world. It's like in the inner party of Plato, and then you're moving to a scientific world where this thing needs to be applied, if you want an analogy. So we talked about domain and application. The adapters are where these use cases can be used. So for example, you have a purchasing algorithm and you want to expose it with an API, or you want to expose this to a user interface. This is still another example. So you see what all this graph they have in common is the circular or let's say the structure which is nested. So there are multiple layers. Again, here we have a domain in the center, an application layer, application or services. Services could be another key word to understand what this layer is. And then when we go on the outer part, we found that they are exposing these services via different mechanisms. So we have, for example, SMS adapter, email, command line. So for example, in the backend, you would have a service, which is, for example, a notification, and the notification can be sent via email or via SMS. And then there's a command line, for example, to interact with them. But the core, so the algorithm of the service is just in one place, which doesn't depend on any external framework or libraries, things like that. So we're going to be inspired by this and also apply this kind of level of abstraction to our example. Okay, so how about we start dividing or creating folders to organize our files. So we start from the inner part. We would have a directory to contain the models, the entities, and then one for the application use cases, and then one for the presentation where we would have the components, the React components. So let's do it. Good old folders. We have, you guys see now we have source and all the files mixed in here with the components, and then we have the data. It's a little bit too messy. It's all in one. It's all compressed into the components. So what we want to avoid is to have all the business logic inside the components. So that's the evil thing to do. We want to separate as much as possible this code from the components code. The component needs to be dumb. They don't need to be aware of how things work. They just need to use the little pieces of the use cases. So let's go source, new folder. Let's do domain. And then inside the domain, models. Another folder would be, let's go with application use cases. And then the presentation. So three levels. The clean architecture, in the clean architecture book, Uncle Bob said that there could be many levels of abstraction depending on the application. But he was also talking about Java application for the backend, or C++, which can be very complex. Like imagine a 3D engine or something really on a complex application. Usually front-end applications, they are not so super complex compared to the backend. So we don't need so many level of abstraction, of course, also because then they will be hard to maintain. So 3 is a good number to start. One of the first things we want to do is to create the model. So we want to describe the data, for example, and the entities that are in play in our application. In this case, they are the nodes, of course. So let's go with describing those. A new file had to be a Wi-Fi node. .ts. And these are just interfaces, really. Interface, as we will need to export. Export interface Wi-Fi node. Cool. And it should be this data shape. So we are kind of doing things in reverse, but why not? So we have the name of the properties, and then I'm subtracting that. I'm making a substitution. Then looks like a string as well. Okay, encryption would be an array of strings. Why is that? Because a Wi-Fi can apparently have multiple encryption types. So literally they are all strings except the signal strength, which would be a number. There we go. So we have our Wi-Fi node. Okay, so what do we do with this interface? Well, we can use it, for example, here, where we are defining the static data. You can see that the Wi-Fi node is of type Wi-Fi node array, right? This needs to be imported. He doesn't know where it is. And boom, we have this typed. So at this point, if we do something silly like this, he's gonna know that the shape of the data doesn't match the type. We are already setting in place a little bit of restriction when we are defining the entities. This is quite powerful because everywhere we will use the Wi-Fi node. We are enforcing, of course, this type of data shape. Okay, so where are we in the graph here? Basically, this interface Wi-Fi node, it would be an entity. It would be an immutable entity of the application. So now that we have it, let's try to write the use case code, which would be loading the Wi-Fi nodes. So we would go application use cases, new file. Let's call it load Wi-Fi nodes use case .ts, and let's define these as classes, even though React is kind of pushing towards the functional programming. Nothing stops us to have our own internal structure in a different paradigm. Actually, it could be a good way for balancing functional programming and the advantages of object-oriented programming. But if you like, guys, this could be a function or rather than a class. Let's go with classes, and let's call it load Wi-Fi nodes use cases. Okay, very good. Here's that completion. He knows that we want something like a repository. Let's keep it super simple. Okay, we have execute, which is fine. So regardless of what we do here, this would be the minimalistic shape of our use case. We want to have an execute method or run or whatever. And here's the magic part. We are describing what we get back from this method. So it would be a promise with an array of nodes. So you see, guys, the fact that here we are just describing promise, we are creating a level of abstraction. So we don't know, or we leave the flexibility to implement that as whatever is required. So it could be an API call, GraphQL, or even loading static data, reading from a file. The important part is that the use case here, we are at this level. The use case is using an entity. So Wi-Fi node, now I didn't import it. Here we are in this tab that I did. You see, we are importing from the domain. So at this specific point, I created a dependency from the use case from the inside. So this is why the dependency is like an arrow like here. The most important part of clean architecture is that dependency goes inward, right? So the external part depends from the inner part, never the other way around. Otherwise, we would break the most important principle. We don't want the core element, the core entities to depend on something like a framework or like a library. So at this level, use case is depending on an inner part on the Wi-Fi node. And here we are creating the contract. We are saying whoever is using this use case has to expect a promise that return an array of Wi-Fi node. So this is in a way simple. It's just a couple of lines of code, but it's very powerful. So we are effectively creating a level that describes what things are doing instead of slapping them all inside the component, the React component itself. So here the advantage is that, yeah, you could say we are writing more line of code, we are creating more files, no doubt about it. But at the same time, we can swap things around. So what we do here, in fact, we will actually do that. We could start returning static data, but later on we would try to use an API call, which would be awesome. But the shape and how these elements are connected, like a Lego, it won't change. So where in all the places of the system where we would use the load Wi-Fi nodes use cases, we are guaranteed to return a promise of Wi-Fi nodes. So I find this is very useful. Now let's return for the moment. We are going to move the static data from the component to here. So let's do that. Let's just copy and paste it. He kind of likes it. You can see up here, I added the outputs. It's working. We are not using that, but soon we will start things breaking a little bit, because what the next step would be. So now we created a use case, we created the interface, but now we have to use the use case inside the React component, which would be in an outer layer. It could be one of these, but we are in an external part. We're not in the use case anymore. The fact is, here's a little bit tricky. I have to do some middle step, which are not super clean, but just to make it work. Incremental step is to use the use case inside the React. So how are we going to do that? Because React has its own way of creating data and loading promises. So we have to use what React offers, and those are the hooks, of course. So let's do that. What we want to do, I just copied some code that I prepared. It's something like this. So I go back. We transform the const of the Wi-Fi nodes into a state, variable state. So we need to use the use state, of course. We're going to say that there will be Wi-Fi node array. And here, as this load Wi-Fi nodes use case is a promise, the execute is a returns a promise, and it's async. I did a little bit more than just adding a method. I'm already imagining, I have in my mind that we need to, in the future, this will be an API call. So of course it will need to be async. We need the code to go to the server, go back. So the mechanism that we will use is the use effect, which has been the topic of many debates, whether this use effect is a good approach. This is just a simple case. So let's throw it there to make it work for the moment. Use effect plus a dependency array which is empty. It will guarantee this to load when the component is loaded. So at load time, we want to execute this part of the code, which will have an async function, and then we call this async function. To be honest, this way of doing things is not my favorite React. It's one of the parts of the React that it's kind of confusing, and the people are also complaining a little bit of the use effect, but it's not too bad. And the advantage of bringing some logic outside is already that we don't have to paste, we don't have to write the logic of how this data has been loaded here. We will just execute it. So let's do it. Use effect has been imported, and then we import the use case. So here's the magic line. We want to have an instance of this use case and then execute it. And of course, we will await. So let's save it. Yes, it's working. And maybe let's do something like this. Let's comment out this and see up there if we get 2 nodes instead of 3. Yes, here we go, 2 nodes. Perfect. Awesome. Okay, next thing. So what we did is we split out that logic of returning a simple array of data into multiple files. What we want to do is this kind of cosmetic thing, but it would be very a nice feature to have for the code, is to create aliases of our importing the files. So instead of having dot slash whatever, how about having something like this, right? The at symbol and then domain, and all the at domain would point to the domain. So we can have multiple aliases, one for domain, one for the application, one for the presentation. And actually it's not too complicated, as the Vite setup would allows us to do that quite easily. So we can define the aliases into the resolve. I just copy and paste it as I prepared it, but as you will see, it's just a matter of adding, importing the path. Let's see, maybe I have to install it. I don't remember, to be honest. Yeah, maybe we have to install it. Let's do it. pm install dev, and it's going to be path. Okay. So their name, let's see where did it install the path thing. Okay, so how do we set up these aliases? We need to go in the vite.config.ts, and then there will be a section which is called resolve, that we need to add resolve alias. and then we can add them like this. So at domain will point to src domain, application, presentation, and then we will need this later. We can start adding them. Spoiler alert. Although there's one thing that we need to be aware of, or it's tricky for me as well. By default, it will start complaining about path and dir name as it doesn't find the types of those. So we need to install like that npm install. It's just going to be a dev dependency types nodes so that it will stop complaining about missing the types. So this is what we need to do from the Vite point of view. We also need to configure the tsconfig JSON with the same aliases. The reason why we need to do it twice is that this one is used by Vite, but this tsconfig.json is used by the VS Code. So in order to work, to make it work properly, we also need to do the configuration of those paths here, adding these lines. Once that is done, the other thing we're interested in doing is by default Vite creates additional configuration file, the app.json and the node, which are these. So just to reuse the configuration here without redoing, we can add extends tsconfig JSON and then extends. Once that is done, what we could do is to restart, restart the IDE so that the changes will apply. And finally, we can start using that. So for example, in the use case here, where we have domain, blah, 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 we can start saying at and then domain. So we also had the auto completion right at, which is pretty nice. See, versus the main presentation. It might seem like a cosmetic thing, but in reality, we are trying to think in terms of domain and then domain components presentation, just having these aliases, and our import would look much nicer. So now that we have them in place, as we go, we will start refactoring pieces by pieces. So another one could be, let's say, where we are using the use case. So in the presentation, I still didn't move them, but nevertheless, let's do it here. We would have, we can say at, right? And then maybe move this stuff up so it's more important. And here is the domain. Okay, so yeah, it's a small change, but let us think more in terms of which components from the from the clean architecture we are importing. So domain and application here, we have that under control. Next thing, we want to tidy up the presentation layer. So that would be something like the most external part of our architecture, and it should be basically the SCSS file and the TSX file of the components themselves. So let's move them inside here, as we already prepared the alias of presentation. Probably we will break things a little bit. Let's see how it goes. Let's start moving the components. Are you sure? Yes. What happens is that VS Code, in theory, where it can, it automatically fixes the imports. So let's see, these are moved, but it's not 100% reliable. We need to check it. Probably it's gonna break something, but let's see. Now the components are here. So in the app, automatically it did that. Unfortunately, it didn't use the alias, but we can do it manually. And also here it's ring. It's like phone is ringing, but it's because we need to create a bar file. Let's for now let's not worry about it. Let's save it. So okay, the app is using the presentation. We might think that app.tsx and app.css, they can't stay here, right? They need to be part of the presentation itself. So let's move them. Both of you guys. I'm gonna go in the presentation. Is it still working? So the main, again, presentation. Save it. Oh, I didn't run the run dev post. Here we go. Yes. Oh, good. So now, should we move the main as well in the presentation? I think it's gonna break things. So it's a little bit of an exception here. Oh yeah, let's CSS, of course. Need to go there. Right. So the main, we think about it later as it's part of the React setup. The important thing to consider is that every component from now on, every React component will go in the presentation folder. So actually, this folder, presentation, will be one of the of this part of the external part of the graph for the clean architecture. Another thing we would like to move are the assets. We don't want them to be here. Actually, I prepared already. If you take a look at the code that we added, tsconfig, so those guys, they need to go presentation, or actually, yes, I'd say let's put them here in the presentation, but then we need to update these. It's up to you, it's a preference. Presentation assets, right? And then the other one, the other place, of course, is the Vite config file, which was not there. Interesting. See a little bit of an error, but no worries. You can say that the assets are going to be in the presentation. Yeah. Does he like it? No. Factory resolve import. Actually, I changed my mind. Let's simplify a little bit. Let's not have an asset folder. It's a matter of preference, but let's remove that. Okay. Here is complaining about the index, and let's say maybe instead of style, a styles folder. Let's rename this guy to CSS, like that. Let's move it into styles. And so finally here we can say add presentation styles. It's going to call it global, but let's call it index CSS. Still doesn't like it because it's used here in the main. Here we go. And this one, I think we can remove it. Yes. Okay. Now it's all nice and tidy. We have the styles, which would be the kind of the global, where we can add the variables, colors, stuff like that. The components, the assets, all in the presentation, and then domain and application folder. So this is good. It's a good way to organize a project. You can go and have different approaches as well, like using hooks, and the hooks would call the more internal sort of logic. For now, instead of using the hooks thing, we would go and use the context, which should be part of the presentation. And with that, we can start sharing the state across the components. It's going to be exciting. And next step would be to try to move this use effect code into a context, so node context, because we want to avoid to have as much logic inside the component itself. And here the component is calling the use case, it's instantiating, executing, but that's a lot of responsibility for a component. And I think that the better place to do that is a context, and we would have also the advantage that we can share the nodes across all the other components. The React context was meant to be used like that. As a first usage is to share the state across component instead of doing the prop drill and pass all the data in the children. So we create a node context file into the context. You see that we are still in the presentation layer. Context has nothing to do with the domain or application. It's something specific to React. It's something specific to a sharing mechanism in essence. It's not that we have to treat it and to put logic, a lot of heavy logic in it. See it in action. So I just pasted this code, which is a skeleton for a context. There's nothing but a create context with an initial value, and then we are printing something, and then just have the value. So basically, the value of nothing. Essentially, is an empty skeleton of a context. Save it, and now the way we are going to use it, it's wrapping around the main component inside the app.tsx. So we're going to have the node context. Let's clean it. Say presentation. Okay. So we have to wrap the main components, which should be a ring, inside the node context. He doesn't like it for some reason. Context presentation. Yes, that's a classic mistake that I always do. It's not context, but we have to use the provider. So let's go with that. Nodes provider. Yeah. Okay, so we're extracting from the context the provider, and then we are wrapping the provider, of course. And from this moment on, everything that we do in here will be shared across the components here, even if there is a complex tree of subcomponents. So this can be used, for example, if we have a loading flag, which is shared in multiple components. For example, a loading bar at the top, and then a loading. That's exactly what we're going to do in a list. We can use this flag all around the React application. Also, we can see here I'm printing a line of bees. Why not? And you can see it up here in the there in the window. You can basically see that it has been printed twice. This can be a little bit confusing, and the reason is that the Vite in dev mode is doing things twice for a restrict rule that we can remove basically, because then when later we will use the call to API, we want to call the API just once. Once we deploy it, this won't be a problem, but to have a consistent behavior, I'd like this to be executed just once. Let's put it this way. So to remove it, we go in the main TSX and just remove the strict mode for now. And boom, now we have it just once. Cool. Next step would be to, of course, we did all this to have like a sort of mechanism where we can move, where we can start moving the related data structure and actually where the data will be saved and shared instead of being here. And instead of being a local state here, what we want to do is move this whole thing inside here. Again, it's not a big list of big chunk of code, but that's how the system is kept clean, but all these bits and pieces. So let's move it. Let's say, let's cut it from here. So you can see what happens is that all this stuff, it's not used here anymore. It's great. We don't want the components to have to deal with too many internal things. It just had to pull it from a provider and use it. So let's move it here. We will have a bunch of import to do. Wi-Fi, of course, the use effect, and then, quite importantly, the use case itself. So let's save it. What happens is that on when the page is loaded, this one will be executed, and the provider of the nodes will be responsible of using the use case, and then essentially use the React way of loading things, the React tools that we have to fire an event or to execute something when this context is loaded. Let's update the context a little bit. In particular, let's improve the initialization of the context itself. I realized that I was using undefined, but how about using directly an empty array? So what we want to say is in the create context, we have a Wi-Fi nodes, and this one will refer to this interface where we are saying that essentially the Wi-Fi nodes is an array of Wi-Fi node. So again, we are pulling from an inner layer from the domain, and we are using this domain here essentially. So we are respecting the rule of the dependency of the clean architecture. Once we did that, we can say, we can basically pass this value down to here, and in this way we can then use it wherever we like in the hierarchy of the components with the use context. So here, for example, ring, we need to pull the Wi-Fi nodes with the use context. You can see this thing is all obsolete, and my favorite part is using Alt Shift O to clean unused imports, of course. So goodbye. And let's get rid of this, please. So you can see up there we have, it's still, everything is working, but to prove it, let's just, instead of the nodes where we are loading, for example, let's pass an empty array here. Let's overwrite it. Boom, it disappeared, so it's working. It means that everything is wired up correctly. So let's say, let's set the nodes back. It's working, fantastic. So this is good. It's a very good point. I showed you essentially most of the strategy to use an architecture, a clean architecture way in React, and use the context in conjunction with the React components and have the logic of how the nodes are loaded brought somewhere else. We're not finished. There's a little bit more to do here because we don't want this one to be instantiated here. So again, let's treat the context as what it is, just for a sharing mechanism. Ideally, we wouldn't have to instantiate this thing here. To be really nice to have dependency injection embedded into React, but React is just a library, so it's up to us to decide how things are instantiated and to create an architecture around that. So that's what we will do next, is to essentially create a maker and create our own way of doing dependency injection, which might be enough for most of the project. So here is what we are going to do. We're going to use the factory pattern, which is one of my favorite. It's very powerful and easy. Essentially, there's a function or some code which is instantiating all what we need for us, and then boom, we get, for example, in this case, we want the use case of the load Wi-Fi to be implemented, to be instantiated, I'd rather say. So new file, let's call it factories, and then make load Wi-Fi nodes use case .ts. It's quite a long name, but what we want to do is export a function. He knows. So you see a function make load Wi-Fi use case, which will return an instantiation of the use case. Look at that. The clean aliases was used automatically. And what are we going to add here? Is this what we want? Yes, it is. So at this stage, you might think that it's an overkill to create again an additional function to instantiate an object, but this will be very powerful when we want to test it, because especially in the case where the use case itself will have multiple parameters, multiple dependencies. For example, the way that the use case is loading the data. So we want to send a specific HTTP client. We might want to use fetch, Axios, whatever. And when we want to test it, we can mock it. So using the maker in this way, adding a little bit of a function, it's a kind of counterintuitive at the beginning, but it will pay later. We will get a lot of benefits later. Okay, so what we want to do now is to use this maker, this factory, and somehow to get advantage of the fact that we can pass the instantiation of the use case directly to the context without having to say new here. And essentially we're passing it as a parameter from outside. So we need to kind of create an interface for the parameters, for the props. So let's add another interface, and then let's call it nodes provider props. He knows. Yes, we want the children, of course. But then we also want the use case, right? So not the maker. We want load Wi-Fi nodes use case, correct, and correct. So you see, it's importing, it's sweet. And now we're going to use this as the type of the node's provider. So instead of being any, we're forcing it to have the use case passed here. Okay, so on this one will be load Wi-Fi nodes use case. Yeah. Its value is never used because at this point we can remove this. We can remove the new thing. We're guaranteeing that we're passing the use case from outside like that, right? So now, as soon as we save this whole thing, you might have noticed or not because it was hidden that the app is complaining. So it's saying node provider now requires something else. So we are kind of forcing the provider to have the use case. And now finally we can use the juicy maker that we built. So here we can say, we grab the make and we say, hey, use this guy and save it. Everything's still working. Let's see if it's true. Again, tampering with the nodes. Yes, they disappear. So we proved it's working. So to recap, essentially, we remove some more responsibility from the context. The context itself doesn't have to instantiate the load Wi-Fi node use case. You just have to grab it and use it. So whoever from the outside is passing it, in this case, we're doing that here, passing it as a prop. It will use the maker, and here we can instantiate the class in the maker. In this case, it doesn't make super much sense because it's just an object and we are to execute a function in it. But as the use case grows in complexity, which will be the case, we need this level of abstraction. We need this empty space where we can target a specific part of the system to test or to pass different type of parameters and dependencies.